Hello students, welcome to Veranda IAS. From the topic of current affairs of science and technology, in this session we are going to learn about the Solar Orbiter mission. The learning objectives of this particular session will be to examine the Solar Orbiter. Then further, we will discuss the Solar Orbiter mission in news. Then we will explain the objectives of Solar Orbiter mission. Further, we will outline the other missions of Solar Orbiter. And then we will explain the information from the orbiter. Now let's begin first by introducing ourselves to the solar orbiter. Now what is it? The solar orbiter will orbit the sun at a distance of approximately 42 million kilometers from its surface. So the point is, as the name goes, solar orbiter. So it is going to orbit the sun. So it is going to orbit at a distance of approximately 42 million kilometers from its surface, carrying 4 in situ instruments. That means carrying 4 instruments with it. Okay. Further, it measures the space environment immediately surrounding the spacecraft. So it will just, wherever region it is there, it will just be analyzing the environment which is there surrounding the spacecraft, similar to the sense of touch, like just like we touch it. Like if I am touching this remote, and it is, I am having the feeling. So it is very sensitive one. If it is very hot, I will may repulse it. But that is the sensory and all those things, not in that sense. But I will be able to sense the environment that exactly exists near to me, near my surrounding. The closest of my surroundings will be observed by this orbiter. Now, prior to solar orbiter, all solar imaging equipments were located inside the ecliptic plane, which is the plane in which all planets circle and is perpendicular to the sun's equator. So this is like, see, this is ecliptic plane. Eclipse, we know the eclipse, and when we talk about ecliptic plane, it is the same thing. Okay. Perpendicular to the sun's equator. The new spacecraft will use the gravity of Venus, remember this, gravity of the Venus and the Earth to swing off of the ecliptic plane and into the Mercury's orbit, providing the first bird's eye glimpse of the sun's poles. So this is important. See, all other missions, if they say this is the sun, all other missions are revolving or orbiting around the sun in an equatorial path. But this mission is special because it will be orbiting in the polar regions. Okay, so it will give us the glimpse of the pole. So it is perpendicular. There here in the second point, it is perpendicular to the sun's surface. So that's why we will first time have the glimpse of the sun's poles. Further, what was the news? In May 2021, the first solar outburst on the sun's surface was captured by NASA and the European Space Agency spacecraft. So that was the news, and that is the reason why we are studying this. Now, coronal mass ejections are another name for these events. So sun surface solar outburst, there is coronal mass ejections which were happening, and this was observed by this solar orbiter and also by some of the spacecrafts of the European Space Agency. If large enough, these eruptions on the sun's surface can send billions of tons of plasma and electrically charged particle hurtling towards the Earth. So that is the thing that happened in May 2021. Further, now let's see the objectives of this mission. If to offer unprecedented views of the sun's high latitude regions in order to research basic physics process common to the solar astrophysical and laboratory plasmas. This is the same thing. This is sun. We have the most of the orbiters around the equator. Now high altitudes means basically like this region, this region. So it will give us an understanding of this high orbital altitude regions of the sun. So that is again like getting more information about the sun, and getting more information about the sun gives us the knowledge about what the sun is all about. Okay. Solar orbiters operating orbit shall have the following characteristics during its nominal operational lifetime. Optimize the reuse of Bepi-Colombo technology. The minimum periphelon radius should be greater than 0.28 astronomical unit. This is factual information. The periphelon radius must be less than 0.30 astronomical units to ensure numerous observations near the sun. So that is another important point. So this is just a factual information which will not be that significant from the exam point of view, but this specifically, the sun's high latitude regions, that is the important point. Like this is the most specific and most important thing about this mission. So you need to remember that. Further, what are the other missions of solar orbiter? Now NASA and European Space Agency launched the Ulysses mission in 1990. this mission Ulysses in 1990. Again, UPSC majority of the times, if some mission is related to the other missions in the past, they may relate it and they may ask a question in prelims specifically, which went over the sun's poles but at far greater distance and without carrying a camera. So it went near the poles, but as it was not having the camera, so obviously you don't have the images of that. Now, according to the BBC's video, the orbiter would use telescopes to shoot photographs through heat barrier constructed mostly of baked animal bones to enable it to resist the temperatures of up to 600 degrees Celsius. So that point is what it will just go nearer, and it has used some technology where it has used the bones. So the bones, according to them, they can resist the temperatures, and once you are getting rid of the temperatures, you can get much better photographs and all those things of the sun in the high altitude regions. Now, by seeing the information about the orbiter, by studying the sun's behavior, the orbiter hopes to shed light on how the former affects technology such as satellite navigation systems, power grids and telecommunication services. Now see, orbiter sheds like there are solar storms, okay, or the solar winds are there, or coronal mass ejections are there. Now they interfere with our communication systems and all those things. So once you have that prediction, or once you have an understanding of that phenomenon, you will be able to have more understanding about these phenomena. So that is the simple thing. The orbital will aid scientists in gaining a better understanding of the sun's dynamic behavior and in unraveling riddles such as the sunspot cycle, which is an 11-year cycle, sunspot cycle, which is now it is going to end in recent times, and why the star spews out high velocity charged particles throughout the solar system. So overall point is, it is going to give us some better understanding about the sun. There are a lot of phenomena going on, and like even as we say, the universe is very vast and our knowledge is limited about the universe. So when you study some particular stars and all those things, you even may have more insights about the other stars in the our universe. And obviously, as a human being, we always try to broader our understandings. So that can be done, and that is the objective of this mission with respect to the sun. So now to summarize what we have learned the solar orbiter, we have learned the solar orbiter mission in the news, and then we studied the objectives of solar orbiter mission. Further, we studied other missions of solar orbiter, and then we studied the information from the orbiter. So it is a very simple information. If new updates comes, now from the exam point of view, what is important now? Solar orbiter and specular features. So this is a topic for the prelims. So remember that one or two, 3 points, and these 2-3 points are if you remember, then obviously you can answer the question which is asked by the UPSC in the prelims examination. With that, I hope you have understood whatever we have discussed in this particular session. That's it for this session. See you in another one. Thank you.